Hi, okay. Let's get these lectures done. Sorry about missing that, miscounting. Anyway, here we go. We're going to talk about the library of functions today. And that's going to be just really general functions starting at the origin that we're going to kind of get in our brain so that when we go to the next section, which is transformations of functions, that we can use these ideas. Okay, so we're just going to talk about these very basic functions. The first function I'm going to talk about is the constant function. And the constant function is unique because for every specific x, every individual unique x in the equation, you're always going to get out the exact same y. And so that produces us a nice horizontal line at b. And that means for every value of x, the answer of y is always b. Okay. Then we have the identity function. That is a linear. The identity function also linear function. And here the slope is equal to 1 because the number in front of the x is a 1, right? And the y-intercept here is 0, 0 because there's no plus any number here. So we can graph this pretty simply. Let me throw a couple of tick marks on here real quick. We start at our origin and we're going to move over 1 in what is uh, the slope. So we move over 1 and up 1 to the next point, over 1, up 1 to the next point, over 1, up 1 to the next point. Also, we could go left and down to get the next point, left and down to get the next point. Okay. And then there's the square function, also known as the parabola or the quadratic. Okay, and here, if we think about the standard form, and I know we talked about that standard form f of x is equal to a times x minus h n plus k. I think we've talked about this. It's been a while. Pretty sure I've talked about it a little bit. I'm gonna look back here and see. Yes, I have. Okay, so when I talk about it like this, the start point is h comma k. This is also known as something called the vertex. Okay, and if we look here at our square function, our h and our k are zeros, so we're going to start here at 0, 0. H and K are 0 and 0. And same thing here. We're going to start here at 0 and 0. Okay. So let's look at the squared function. Okay. And we'll start here at our 0, 0. Now, we don't want to have to make a t-chart. We don't want to have to compute out a whole bunch of stuff. We want to just use what we can to just redraw this graph without doing those things. And the way that we do that is by doing what the function says. So here, I'm going to start here at my little vertex. I'm going to move one spot in the right direction. So one spot in the positive direction. And I'm going to say, what is 1 squared? Because that's what the function is here. And 1 squared is 1. And that's going to give me my next point. I'm going to go back to the vertex. I'm going to move over 2 spots in the positive direction from the vertex. 2 squared is 4, so I'm going to go over 2 and up. 4. Now we're going to go back to the vertex, and this time I'm going to move 1 spot in the left direction, so I'm going to move a -1. And -1 squared is also 1. And I'm going to go back to the vertex. I'm going to move over -2 squares, and -2 squared is +4, so I'll go up 4. And that gives me enough points. I cannot draw today. It's hard The fine motor skills are not really there with me today. My medication, but I'll try to give it to you. There you go. Okay. So that looks like a quadratic function, right? So now let's do the cubes here. So let me do, maybe if I space it out a little bit more, it'll be a little bit easier. 1, 2, 3, 4, 5, 6, 7, 8. Of course, I have to go. 1, 2, 3, 4, 5, 6, 8. Just do it like this. Okay. So we're going to start right here at our 0, 0, because 0 cubed is 0. Yeah. Okay. We're going to move one spot right over. So what is 1 cubed? 1 times 1 times 1 is 1. Back to the vertex over 2 spots. What is 2 cubed? 2 cubed is 8. Back to the vertex. What is -1 cubed? -1 cubed is -1. What is -2 cubed? -2 cubed is -8. So this is our graph of this guy. Okay, on up to the right, down on the left. So let's look at the square root function. Square root function is unique in the sense that the square root function is not symmetric necessarily because we can't do the negatives. I mean, it is technically symmetric with respect to the y-axis, but it's difficult to actually see that symmetry because we only have one side of the equation. Again, if we look here, we can see that our h and k is 0, 0. So that's where we're going to start. And the square root of 0 is 0. I'm going to move over 1 to the right. The square root of 1 is 1. Back to our vertex, we'll move over 2. Square root of 2. Do you know what the square root of 2 is offhand? I don't. How about square root of 3? Do you know the square root of 3 offhand? I don't. But we do know the square root of 4. 1, 2, 3, 4. And the square root of 4 is 2. Awesome. We know square root of 4 is equal to 2. So yay, we're going to use that one. Now how about the square root of -1? That's equal to an imaginary number. We cannot take the square root of negative numbers, so this is what we've got. Okay. Now the cube root works differently. We can take the cube root of negative numbers. The cube root of a negative number is a negative solution. So like the cube root of -1 is equal to -1. Cube root of -2 is just the cube root of -2. There's nothing to come out of that. That's just it. The cube root of -8 is equal to -2. Okay. All right, so let's draw this up here. And I'm going to start again here at 0, 0 because there's no shifting going on here. And the cube root of 0 is 0. We're going to move over 1 to the right. The cube root of 1 is 1. Move 2 to the right. The cube root of 2, you don't know the cube root of 2. What's the next one you know? You know the cube root of 8. The cube root of 8 is 2. Cube root of -1 is -1, and the cube root of -8 is -2. Okay? And as you work with these, you'll get better with them, of course. Okay, and then let me stop here since I know I feel like I'm going to miss it. On. Where did it go? Today's silly phrase. My reflection blinked first. My reflection blinked first. Okay. So I'm just going to introduce this other function. It's called the greatest integer function. It's also known as the floor function, and it can be written in two different ways. The most common nowadays is that you see it with this int word in it, but back in the day, this is how it used to be represented to me. And the idea is that it is the greatest integer less than or equal to whatever the x is. And so let's just for fun, just for understanding also, let's just make this little t-chart here. We'll do all sorts of okay. Okay. So, and what we're doing here is y is equal to int x. So we're just doing the greatest integer function. And I'm going to kind of start with the positive numbers. Okay. So the greatest integer of 0 is 0. That's the greatest integer part. The greatest integer of 0.2 is also 0. And the idea is if we think about this like a number line, we've got 0, 1, 2, -1, -2. Well, 0.2 is going to be right here, and the biggest integer part for 0.2 is 0. Okay. Same thing with 0.8. 0.8 is right here, but the biggest integer for 0.8 is 0. 1.1 is right here, and so the biggest integer for 1.1 is 1. And 1.7 is right here, and the biggest integer for 1.7 is 1. And 2.1 is right here, and so the biggest integer for 2.1 is 2. Now, it makes a lot of sense when we're talking about positive numbers. The negative numbers tend to give you a little bit of trouble. That's why a picture is really helpful. If we talk about -1, -0.1 here, the greatest integer is -1. Remember, it says the greatest integer less than or equal to x. -1 is less than 0. This is also going to be -1. -1.1 will be right here, so that falls under -2. -1.9 would be -2. -2.3 would be -3. Okay, now we can kind of take this information and get an idea of what a graph would actually look like here. And so let me do that. And I'm going to literally just go like this. So in between -1 and -2, -1 and -2, it is -2. And then in between 0.05, -0.5 and -0.1, it's going to be -1. Now between 0 and 1, it's going to be 0. I don't know why it drew me an arrow there. I didn't try to make it draw me an arrow. It did. And then between 1 and 2, it's going to be 1. . And then starting here, it's going to do something to that effect, right? And that's what the greatest integer function looks like. Now, you won't really be doing very much with this. It doesn't really come up in pre-cal. It shows its ugly face in the calculus sequence, but it's good for you to have a little bit of exposure to it before you see it and have to do anything with it. Okay. And then finally, let's talk about the piecewise function. And the best way to describe a piecewise function is the absolute value function. And that makes sense because, you know, the absolute value function, if you plug in a negative number, it makes it positive. If you plug in a positive number, it stays positive. And we already know how that works, right? So if we wanted to graph this, starting at 0, 0, here when x is 0, greater than or equal to 0. So when x is 0, we get 0. When x is 1, which is greater than or equal to 0, we get 1. When x is 2, we get 2. When x is 3, we get 3. Now, when x is negative 1, we get positive 1. When x is negative 2, we get positive 2. When x is negative 3, we get positive 3. And that is our graph. Now, what happens if it's not the same, right? We got two different things going on here. So let's graph it. You're going to graph it by pieces. That's the way you're going to want to do it. And we've got the two pieces here. So basically we have a line when x is less than 0, and we've got a parabola or a square root when x is greater than or equal to 0. So let's go ahead and okay, now we're dealing here with the square root. We've got it's definitely starting at the origin of 0, 0. So a square root of 0 is 0. The square root of 1 is 1. The square root of 2 we don't know. The square root of 3 we don't know. The square root of 4 we know is 2. So that gets that piece going. And now when we look at the line here, what is our y-intercept? Our y-intercept is 0, 0. Slope is equal to negative 2 over 1. So if we start here at 0, 0, we're going to rise a negative 2 and run 1. Rise a negative 2 and run 1. And so that is our not great line, but you can see that this guy is supposed to be a line. I don't know if it'll let me erase any of that. Close enough for government work. Tell me to stop. I'll stop. Thank you. Let me just stop. Okay. Now, let me ask a couple of questions here, just for fun. What's the domain? Starting from the left, we see arrowhead. Ends with arrowhead. Our domain is negative infinity to positive infinity. How about our range? Starting from the bottom, arrowhead, going to the top, arrowhead, looks like our range is negative infinity to positive infinity as well. How about increasing intervals? Starting from the left, it looks like we're just going uphill all the time, actually. So it looks like from negative infinity to positive infinity. Decreasing interval? None. What else could we ask? Intercepts. There's only 1, 0, 0. Okay, now I think I need to fix this problem. I need to fix this problem. So I'm going to pause and fix this problem real quick because it's just not good. And then we'll come back and finish it up. Okay, so I think I fixed it now. And let's move on with this guy. Okay, first things first, it asks us to find g of -2, g of 1, and g of 2. So let's just do that first. G of -2. Now, when we're dealing with a piecewise function, this piece right here, these are your conditions. This tells you where x has to be to deal with these specific outcomes. And the outcomes depend on the conditions. Okay, so if I want to evaluate g of -2, I have to look at the conditions and find what problem -2 actually goes to. And the -2 is in this first region right here, and that is from, so I'll use the equation -2x plus 1. So I'll go -2 times my -2 plus 1 gives us 4 plus 1 equals 5. So g of -2 is equal to 5, and we could write that as the point -2, 5 for the graph if we wanted. Okay. G of 1, now you look here at the conditions, you see that the first condition is between -3 including and not including 1 up to 1. The last condition is greater than 1, but the middle condition is if it equals 1. So g of 1 is equal to 2. Okay. And then finally, g of 2, we have to decide where does 2 fall in. 2 is greater than 1, so this is the bottom here, and this is going to then be 2 squared, which is 4, and so we get 2, 4. Okay, so there's the first part. Got that done. Now let's graph it. All right, now what I am going to do is put in all of our tick marks here. Now you can graph by these values over here, but I'm going to do it a little bit different. First things first is I'm going to plot our 2, 1. So when x is 1, y is 2. We know that that is a for sure point there. So I'm going to put that there. And then we also know when x is greater than 1, that it is a parabola starting at 0, 0. So at 0, 0, we go 1, 1. So that one doesn't count. 2 and 4. So we're going to get this curve right there. That goes on forever. And then finally, we will manage our line here. What is our y-intercept? It is at 0, 1. So here's our y-intercept and our slope. M is -2 over 1. So we're going to go down 2 to the left 1, down 2 to the left 1. And there is our graph. Yes, 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 yes. I think, oh, and it only goes to -3. My bad. I knew I was missing something there. Here, we're dealing with between -3 and 1. So to do -3, let's keep on drawing this down here. And there we go. Okay. So we've drawn our graph, got all 3 of the conditions. We've got our piece of the parabola right here. We've got our single point here. We've got our linear line here. It doesn't go on forever because it ended at -3. So let's do our domain here. Our domain is from -3 to -1. Union, there's nothing. I'm sorry, not -1, that's a 0. -3 to where x is equal to 0. Union where x is equal to 1 to infinity. That is our domain. What is our range? Well, we'll have to figure that out. When we stick in -3 here, -3 times 3 is 6 plus 1 is 7. Hey, did I do something wrong? Sure did, but I don't really know why. This looks weird. So it should be the way that goes, and it's going to go up. Well, let me pause for a second because my brain is not allowing me to think right today. Hold on.